Okay, well, what do we have here? Well, it's a triangle, and there's another line that kind of goes off this way, and there's a point C that I thought I'd indicated, but I don't really see it there. Okay. Now, if this angle is 3x, this angle is x plus 20 degrees, and this angle is x, then what are the three angles? Okay, people had no problem. They responded pretty quickly. Well, these three angles add up to 180 degrees. So we can write an equation. This angle 3x plus this angle x plus 20 degrees plus this angle x add up to 180 degrees. Or, yeah, total is 180 degrees. Okay. Well, first thing we do is we simplify the left-hand side. The right-hand side is also already as simple as it can get. So we have three x's here, an x here, and an x here gives us 5x, and we have the 20 degrees. So 5x plus 20 degrees is 180 degrees. Subtracting 20 degrees from both sides, we get 5x equals 160 degrees. Then dividing both sides by 5, we get x equals 32 degrees. So if x is 32 degrees, we can come back up here. 3x is then 3 times 32 degrees, or 96 degrees. I know this doesn't look like 96 degrees, but remember what I said previously. The figure doesn't have to be realistic. If the angles have this relationship, then if we wanted to make the figure realistic with this relationship, we'd have to redraw the triangle. This would have to be 96 degrees. This would have to be 52 degrees. Because, of course, x plus 20 degrees would be 32 degrees plus 20 degrees, or 52 degrees. And this is just x, so this is 32 degrees. And we can add these up. 32 and 52 is 84. 84 and 96 is 180. So we have 180 degrees in the triangle. Okay. Now, we want to talk a little bit about perimeter and area. Okay. Here's a figure. What's the perimeter of this triangle? And of course you can identify this as a triangle. Well, perimeter is how far it is around the triangle. 7 units here, 11 units here, and 12 units here add up to 30. So it's 30 units around the triangle. That's what's meant by the perimeter. Okay, here's another figure. We have a right angle here, right angle here, right angle here, and right angle here. So what's this figure? Well, that's a rectangle. Okay, rectangle is a four-sided figure, a quadrilateral, with right angles at each vertex. So we know that it's a rectangle, and I ask what's the area if this is 4 and this is 10, and people tell me, well, it's 4 times 10, which is 40. And then I ask why, and nobody can tell me. Okay, failure of our education system. Why comes back to because this. Okay, what's this? Well, we divide the rectangle into 4 strips corresponding to the width of 4. Each strip has a width of 1. Okay, and then well, I'm sorry, not each strip. Each strip has a width of 1. That's correct. Okay, then I divide it into 10 blocks this way. So each strip is divided into 10 equal blocks corresponding to the length of 10. So that now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units here, which matches the length of the rectangle. I have 1, 2, 3, 4 units here matching the width. And what I have now is 4 rows, each with 10 blocks in it. So there are 40 of these little blocks. Well, each of these little blocks is 1 by 1, 1 unit by 1 unit, giving us 40 1-unit squares. That's why the area is 40. Okay, so what I said here is, okay, you know area is length times width. That's the formula for the rectangle. If you use the formula mindlessly, you know, have a formula, transpose my U and my M. Okay, yep, any case. Here's the formula, or the formula. No, it's formula. That's a formula. Okay, you have a formula here. something you can memorize and use, but you completely lack the meaning if you don't understand the reason for the formula. Now, there are formulas that you're never going to understand the reason for. Okay, there are formulas that come from calculus, formulas that aren't worth memorizing because you're never going to use them, but there are a lot of formulas out there, and nobody knows every possible formula. We can generate formulas ad infinitum. Okay, anyhow, here's the formula. Here's the reason for the formula. You multiply the number of little squares in a row, which in this case would be 10, by the number of rows. That's why the area of a rectangle is length times width. There's a little more to that. What if you have fractional lengths and widths and so forth? Then you use fractional squares. But let's not worry about that. Let's just worry about the basic idea. This is important.